We're going to go ahead and get into some more linear programming, just a continuation of the previous section. So our objective again is to find the max and min of a function over a region, over a shaded region, over the feasible region. So let's jump right in. We're going to maximize and minimize this function right here, subject to these constraints. So that, again, that is nothing new there. So let's go ahead and get started with the graphing. Like we often do, let's work our way up from the bottom. So these right here are the axes, we know that. So there is x is greater than or equal to 0. There is y is greater than or equal to 0. Again, greater than for both of those, so we are shading above and to the right of 1. So working our way up. If I have to change this, I have to change this one around. I think intercepts are both 0, 0, so that doesn't help us out a ton. I'm going to move the y to the other side, and I get y is greater than or equal to x. So that's now in slope-intercept form. My starting point is 0, 0. My slope is 1. So I'm going to be going up 1 over 1 every time, and it works out pretty well in that regard. So again, here is that function. I'm looking at this, I'm going to end up going by 2s. That doesn't change this graph at all, but my scale is going to be by 2s. So x plus y is greater than or equal to 10. That's going to be actually 5 on our graph. So my intercepts here are 0, 10, and 10, 0, but in our case it would be 0, 5, and 5, 0. And then lastly, my intercepts here, again, if I get rid of the x to go for my y-intercept, that's going to be 20, 0, 20. And if I get rid of the y and go with the x, it's going to be 60, 0. So again, that's why I'm going to go by 2. And even it doesn't matter a ton. So I'm going to start here at 10, and I know 60 ends up being way down here. Oh, I don't even know where. Yeah, I can't. Probably right. I think that's about. That should be roughly where we're at in regard to that being. Again, we'll find out. It doesn't matter a ton. So I'm going to find out again after I figure out where to shade and things like that. I'm going to find out that my feasible region is this region right here. So that's going to end up being where I shade. So you all know how good of a job I do shading. And this is no different. This is going to be very pretty here in a second, as are all of my shadings. Beautiful. So let's start to go ahead and get our corner points. So this corner point right here doesn't fall on an axis. This corner point right here doesn't fall on an axis. This does. And so does this one. Again, remember our scale is by 2. So this ends up being 0, 10. And this ends up being 0, 20. So now we need these right here. We don't want to estimate. We want to actually find out what these points are. We talked about this in one of the classes on a previous day, but trying to figure out how we do this. We have to go back to section 7.1 and remember how we find the intersection of two lines. That ends up being a system of equations is all. So let's start with these two lines right here and looking for this intersection, looking for that corner point. So this line, we're going to take this equation right here, and then this other line is this top one. So we're going to take those two equations, so I'll write them over here in blue. X plus 3y is less than or equal to 10. I'm sorry, that's 60. And x minus y is less than or equal to 0. You know, we're looking for the intersection, so I'm going to go ahead and change these to equal sign. That doesn't change anything. Make this a little neater. So let's start by getting rid of the x's. So I'm just going to multiply the bottom equation by a -1. That becomes a negative. That becomes a positive. So a big plus sign then out front, a big equal sign, x minus x, those cancel, 3y and y is 4y, equals 60, y equals 15. So y equals 15, now let's plug it back in. Again, it doesn't matter where I plug it in. I'll plug it in right here because that works well for x. Plug it into this right here, so clear that out of the way. I get x minus 15 equals 0, so x would equal 15. So that tells me that this point is 15, comma 15. In the same way down here, again, we can kind of estimate it for, if we went by ones every time, we have a better idea. But again, we went by twos this time, partially so I can show you how this works. So again, let's work with these. We're using this equation now, and the equation right above it with x plus y equals 10. So let's work on that right here. I have x plus y. Again, I'm going to put equals there because we're looking for treating this as a line. And x minus y equals 0. So I don't have to do anything. Those cancel. I get 2x equals 10. X equals 5. Easy enough. Now let's plug it back in right here. X is 5. So I can go ahead and plug that into 5 minus y equals 0. So y is also going to equal 5. So my ordered pair for this point right here is 5, 5. So again, the key to this lesson is just showing you, if you can't tell exactly where they cross, set up a quick system of equations, solve it for x and y, and that'll tell you on the coordinate plane where we're at. And so now let's maximize and minimize this real quick. Again, that process goes quick. F of, let's go 0, 10 equals 5 times 0 plus 15 times 10. Let's go F of 0, 20. 5 times 0 plus 15 times 20. F of 5 comma 5. 5 times 5 plus 15 times 5. And F of 15 comma 15 equals 5 times 15 plus 15 times 15. So going through here, 5 times 0 is 0, 15 times 10 is 150. 5 times 0 is 0, 15 times 20 is 300. 5 times 5 is 25. 15 times 5 is 75. So 15 and 75 gives us 100. And 5 times 15 is 75 plus 225 gives us another 300. So after we see all that, we can see we have two maxes. There is a max of 300 that happens at two places, at 15 comma 15 and at 0, 20, and a minimum minimum of 100 that takes place at 5 comma 5. And that wraps up this.